So applications which are composed of independent services that communicate over well-defined API. That is the most important aspect of a microservice. There should be a well-defined API. API is basically an interface. An interface which we expect to be same for whatever way we communicate to it, right? So if I am answering a phone, then there is a method I am following. Whenever I answer a phone, I say hello, or I ask who are you or why you are calling, kind of stuff. So that interface kind of way remains same. I'll give you some more example on the interface side of API, but API is basically an interface by which you communicate to someone else. We will discuss how interfaces work. So what you are seeing here, that my monolith application or architecture is having all these components, your user interfaces, business logic talking to each other and having one database. But if I'm looking at microservice architecture on the right side, things are looking differently here. What I'm seeing that there is a central place which is a user interface. Now, this says it is a customer facing application, but it may happen that this application may not be customer facing. So user interface may be missing. What happens now that through this, all these independent services are talking to each other. And another aspect which you could be very important to understand here is that these databases are different. We call it purpose-built databases. We don't want to keep data into one single format databases. It may not work well for all of it. It may not be well suited for all type of workload, and we may want to keep this data into different architecture, different databases. Sometime I would prefer to have a NoSQL database. Sometime I may prefer to have a graph database. So it depends. But idea is that every microservice is then ensuring that we are keeping their data into a database. This is what we call purpose-built database. They are using a very specific database for a very specific cause. Right? So that's how your microservices would work. Now, when I say database, it doesn't always have to be have database. What I prefer to call it that there is some persistence layer. What is a persistence layer? Something where I would be keeping some data, and that could be maybe a queue, that may be a database, that may be a S3 bucket, it could be anything. But what we are trying to avoid, that we don't want these two services to talk directly in the sense they should not be depending on each other. In between them there should be some mechanism to hold data. So service A wants to talk to B, it will push data here, and B would pull data from this queue or storage and get started. Like in your example of a restaurant, when a waiter has taken your order, it won't wait for the chef to listen to the whole order. He would have written it onto a page or onto electronic system, and this would be transferred to the chef. So that's how chef would know what needs to be prepared. That's exactly what we are trying to do. We have stored our data, we persisted the data somewhere. If this page is not there, then this waiter has to wait for chef to be available and explain everything, which is not at all a good design. And we are ensuring that they communicate, but they make sure it could be a different. Devasis's question is, the persistent layer can be SQS Kafka. I would say it could be anything. It could be anything. It could be a caching service. It could be a SQS queue. It could be Kafka stream. It all depends on what kind of architecture you are building up. So if it is a real-time architecture, probably Kafka or Kinesis would work best in that case. But if this is an asynchronous architecture, maybe SQS, maybe S3, it could be anything. So it doesn't need to be a specific database or a service. Anything which could hold data for a while till somebody else picks up, and that's what you could use as a persistent layer. So should not be a problem at all right. Hopefully everyone is following along and understanding the concepts related to microservices. Now, is microservice going to solve every problem in your environment? I would say probably not. We would need to think whether a microservice is required or not. And I don't expect that from very first beginning, let's say you are starting a project today, that from very first day you would start doing microservice architecture. If you're doing it, probably you will hit a lot of roadblocks. So what we want in this particular case, we want to have a different approach, and this is well documented into a nice article, and I would highly recommend you read that. That is coming from James Fowler, sorry, Martin Fowler, and this is the reference. I will put that into the resources page, and that talks about monolith first approach. Idea is Going directly to microservice architecture is risky. Yes, we want to build a microservice architecture, but start with a monolith. Try to see that what component have dependencies, what can be broken down into smaller pieces. So you start bigger first and then start drilling down that okay, one component can be made separate, complexity rises, start breaking out some of the microservices. So that is how the approach should be. I don't see expect people to directly go to microservice architecture. Maybe at least they would start with this and then realize that hey, this one is going to be a bottleneck and we have to fix that problem, and then we may want to start that breaking down process for our application. And we have a lot of tools available, services available, in which you can do that through a no downtime approach. And I'll send you some more links today if you want to follow this approach, that you had a monolith application and then you break it down into smaller micro services and still do not have any downtime at all. So those all options are available. So hopefully everyone has little more idea on how it actually works. So it's a nice article called Monolith-first, and it talks about like what can be challenges and what kind of things you should be taking into consideration. Okay, what else? Now, microservices would have a very specific thing. What is the specific thing we are talking about? So first thing we would have is a polyglot persistence. Now this is like a UI issue here. What is polyglot? Polyglot says that we want to have an architecture in which we are not dependent on a specific technology. So what we are looking for here is a polyglot persistent. Let's say my application requires these four components to work. They would talk to this and this. Maybe just give me an example. If I feel that first component is better suited into Java, second would work best into PHP, third will work best into .NET, and fourth will work best into Node.js, no problem at all. So we can go ahead and say, hey, it is a polyglot persistence. And then polyglot persistence and polyglot framework means you may use any type of databases as a persistent layer and any type of languages to get your work done. So that is what we mean by a polyglot persistence. So polyglot persistence is something you should be taking into consideration when you are building microservices. Microservices are decentralized. We are not trying to put everything into a central place. We are trying to decentralize this as much as we can. And then what else? We are trying to go ahead and have a polyglot persistence. We are then doing what? Do one thing well. When a microservice is there, it would be doing one thing at a time, and that would be doing it well. Like if in a restaurant business, if I'm a chef, I know about how to cook things. If I am a waiter, I know how to take order or what recommendation to give to customers. If I'm a bartender, I would know what kind of drinks would be mixing well and what won't work for a particular person. So that's what I'm doing. I'm doing one thing well. Instead of a taco stand where that person is doing everything, we want any specific thing to be done by those individual. And that's why we say that microservices do one thing well at a time. Okay, what else? Other characteristic you will find that they are independent. Independent in the sense that they are not directly talking to each other. There would always be a layer in between, and that layer is ensuring that if there are some challenges with one tier, it would still keep on functioning without any issue. So that kind of independence is built into microservices. If you created a microservice and A is trying to talk to B at the same time, then it's not a good design, because if A fails, B would also fail. So we don't want that, and we want to make them as independent as possible. Okay, what else? Other things which you will find here useful will be that microservices will become a black box. Idea here is I just talk to that interface. Is it returning value based on Java function, or was it written into PHP, or they changed .NET at the backend? I don't care. For me, it is a black box. I have a microservice endpoint where I send my request and I get my response in a specific format. What they are doing at the backend, none of my business. Like when you go to a McDonald's drive-through, what you do first? You first order, right? Then you pay for it. And third thing you do is collect that particular order which you have placed. Who is working at the back end? Are they using microwave? Are they using a fryer which is running by solar heat? Or is it using a specific type of brand of the oil? It doesn't matter. So interface would remain same. Any McDonald drive-through I go through, I would have the same thing. I would first order, second thing I would do is pay, and third thing I would do will be collect. And how they are managing the at the back end, I don't care. So everything for you remains a black box. So you provide some input and you expect some output in a specific format. That's how your black box services would be working. Another approach with microservices are is that you build it and you run it, right? What we want to ensure that you are not just throwing away your code to development, sorry, your operation team to deploy. If you have built your application, you would ensure that you are also maintaining it. So you build it, you run it, you break it, you fix it. This also solves a problem of communication between development and operations team. So microservices are designed with a mentality that individual team would be talking about and would be maintaining those services, and they would be running these services also. So hopefully everyone is clear and got a little bit more idea on how all these things would be working. Is it recommended to have microservice being stateless as a characteristic? VK, I would say yes, probably. Otherwise, if you are creating a service in which A talks to B directly, then you are again just creating a bigger monolith. That's all. So most of the time, they would have a well-defined way, they would have a persistent layer, and they won't be talking to each other directly. There would be somewhere in between where the data would be persisted for communication. So most of the time, yes, they has to be designed in a stateless fashion, and then only you would be able to scale it. Otherwise, there will always be challenges. Right. So what you could do, let me try to give an example here. Let's say if you are trying to do things like that. Let's say this is your service A, and this service A wants to talk to B. Now, if you are sending data directly here, and if B is not available or A is not available, then your architecture is down. Instead of that, what you could have done, maybe added a caching layer in between. A doesn't talk directly, A send data to caching, and then B pulls data from this caching tier. So even if A is down, but if the caching layer has data, B can keep on functioning. If B is down, A can still keep on functioning because it can keep on adding data into caching layer. So that is a better way to do implement. And if it is stateless, stateless means we are not keeping any state information, then it is easy to scale it to more front end or more back end. So probably you would keep it stateless most of the cases, not always. So it, I would say, depends, but approach should be to not them talk to each of them directly. Otherwise, you are defying the purpose of building a microservice altogether. Okay, good. Now, let me give a simple example of how the interface works. What you are seeing here is set of wheels, right? Question, what do you see as a common thing in these wheels? Do you see anything common in these wheels which I'm showing? Obviously, all are made up of rubber and steel. That's fine. The tires are there. That's true. What else? What else? Yeah, tires. Shapes. A wheel should be circle, isn't it, Farna? It would be very complicated. Round and glossy. Tire size. Tire sizes can be different also. Wheel are circular. Exactly. Shape is same. Yes, that's what I expected. Let me give a little more idea on that. Let me try to talk about what I'm looking for. If you are looking for fixing this wheel into an vehicle, how you fix that? So to fix that wheel, you need to see this section here, right? See this section here. See the section here. Do you see any similarities in between these? Anyone? Do you find out any similarities between what is this section? Right. Some of these folks may have Rocket League wheels. All of them have five. Exactly. That's what is happening. So what I'm seeing here, that if the place or the vehicle in which I want to fix this wheel, if it has the same interface, whether I go with the sports type wheel or whether I go with a traditional type wheel or with more spikes in that, it doesn't matter. It's the same interface which we are following, and that's exactly what microservices are allowing you to do. They are allowing you to have a standard set of approach. So in any vehicle, if you have this five center point which are same, that is your interface. So that interface is same. That would mean that we are able to attach any supported wheel inside. That's what an API is. That's what an interface is. So hopefully that gives you idea that interface is same, and that's why any wheel can be attached into this vehicle should not be a problem. Now I'm not saying that every vehicle would have 5 set of nuts and bolts, but I'm just giving an example here so that they would be able to fit in. And whether I replace wheel or not, it doesn't matter because these wheels are having the same standard component, and that's how I could get connected. So that's what my meaning of is a interface is the same, and then you could build that application through Java or PHP or .NET. It doesn't matter at all because you are talking to the same interface all the time.